All right, this video is going to talk about systems of inequalities. We've been solving systems of equations more than likely in your class. And now we want to talk about inequalities. Now remember, a system of inequalities or any sort of inequality has multiple solutions. So these would be things like when we're graphing y is less than x plus 2, this second inequality up here. Well, we know that we're going to go up 2 units, right? And we have a slope of 1. So if I went right 2 units, I could go up another 2. Right, I'm going to get a nice equation here, and notice that no equal sign in that inequality here, right, means that we're going to draw a dashed line. And in fact, if I went down 2, I can go left 2. Let's get this thing fairly precise here. Right, we're going to get a nice dashed line. And because y is less than, right, I know I want all the points below there, or if I plugged in something like 0, 0, well, obviously 0 is less than 2 is a true statement. So I'm going to shade towards 0, 0. So I want to shade everywhere down, right, below here. But I don't want to shade too much too quickly because I don't want to really get ahead of myself here. I need to remember I also need to plot the line up top. Y is greater than or equal to e to the x. Well, remember that anything to the 0, so I know that if I plugged in 0 here, I would get back a 1, right? E to the 0 is 1. So I'm going to plot my point here. I also know things about exponential equations. So again, it's going to have a horizontal asymptote on the y-axis. So I want to graph sort of along that axis and then curve upwards. And we know that, well, e to the first power is 2.7-ish. So it's going to be right around there. We're going to cross through there at some point. And even though I want to graph below the purple line, right, we already figured that out. I also want to graph y is greater than e to the x. I want to be above the red line. So where I really want to be is just in this sort of sliver here, right, between the purple and the red. Make sure we can still see that purple dashed line, but again, I want to be between the purple and the red. One thing that really helps provide some accuracy here, number one, of course, is labeling. So we probably need to label some tick marks here. But I should also, if I can, provide those points of intersection. I definitely need to shade correctly because there's an infinite number of answers between the purple and the red lines. But knowing where these 2 points of intersection would also be very helpful. And that's where your calculator can really come into play. I'm going to go ahead and hop on there real quick. Notice I've already pre-typed e to the x and x plus 2. Now you could go over to the left side here and you can talk to your teacher about that. And we may do that in the next example. We can change these straight lines into sort of shading. But to be sure that I can find the points of intersection, I'd rather just graph the lines. So I'm going to go to Zoom Standard so I can see them on the screen here. And I want to find those 2 points where we're crossing. Right? So again, second, calculate points of intersection, number 5 here. Enter, enter. And I want to go near one of them. And we get 1.146, 3.146. So again, I'm going to say this is the point 1.146, 3.146 on there. And I also want to find this point of intersection down here at the bottom. So again, I'm going to go back to my calculator. Remember, just press second, calculate, intersection. Again, the blue one, the red one. But now I need to make sure I move my guess so that I go find this other point of intersection, right? Let's make sure we're down here. Negative 1.841, or 841. So we're going to say this is the point negative 1.841, comma, and then, since my memory is not so great, 0.159, 0.159, right? And again, that's that point of intersection down there at the bottom. Finding those points of intersection, again, just gives us a little more accuracy. But again, all of the points in the black region are really not even those 2 points, since they're on a dashed line. They wouldn't have made that second equation true. But all the points in the black region, right, that feasible region, as we sometimes call it, would be possible good answers. Now, again, we know a lot of different functions, so we can take a good look here. We can get some kind of crazy looking graphs sometimes. It might ask you to graph some trig functions. Or up top here, again, we've got x squared plus y squared equals 16. Immediately I know that that's a circle of radius 4. So what I'm going to do is go ahead and plot out 4 units each direction. Then I'm just going to do my best to draw a nice round circle here. Getting a little oblong, but that's okay. I also know that the second equation, y equals x squared, is a simple parabola. So I can go ahead and plot it 0, 0, 1, 1, 2, 4. And I know that I've already sort of exceeded. I've gone outside of, right, my circle there. So again, being that we know things about a lot of functions, you may be asked to work with a lot of different functions. Now, since the top equation is not solved for y, checking a point like 0, 0 is always a great idea. And we can just say that 0 squared plus 0 squared, well, is that greater than or equal to 16? And I would definitely say that's false. So we don't want to include 0, 0, right? Or what we basically want are all the points x squared plus y squared that are beyond, right, greater than or equal to 16 units or 4 units from the center. So I want to be outside the circle. I also want to be below, notice the parabola, y is less than or equal to x squared. So I want to be sort of outside the blue, right, below the blue, but I want to be outside the circle. So I'm thinking that we want to be shaded out in this area, right? Again, below the circle, below the blue. So we're going to be out in that area, right? Got to be outside the circle, but again, beneath the parabola. And again, you could always go find these 2 points of intersection very simply. Let's go ahead and do that quickly because plotting a circle on your calculator can take a little bit of work. So I'm going to go back in here, y equals, we're going to clear out the 2 equations we have. Again, a simple way to solve for y, let's do that on our screen here, is to say that y squared would have been greater than or equal to 16 minus x squared. And again, we got to take the square root of both sides. Now, I'm not that worried about the shaded region, so I'm just going to call this an equal sign. Y equals then plus or minus. And again, remember that square roots don't distribute, so we need to type that whole statement into our calculators, right? So y is going to be equal to 16 minus x squared under the square root. So I'm going to say the square root of 16 minus x squared. And again, you could retype that as negative, right? That same statement. Or a quick shortcut, variables, y variables. I want to pick y1 from the function menu. I want the negative square root of 16 minus x squared. Now that's going to be the bottom half of the circle, which really, when we think about our picture, wasn't where our point of intersection was anyways. So if you don't want to put that part in, that's sort of your option. But the one I do need is that x squared would be my other formula, right? So again, there's my circle, there's our black line, and we're just looking for these 2 points up top, right, where the black line and the blue line intersected. So second, calculate the intersection point. And the nice part is there's a lot of symmetry going on. Oops, I picked the red line though, so I better start over there. Intersection point, blue. Now we need to make sure we get to our parabola, so the black line. And again, I'm just going to move to the right. 1.879. So again, this point here is 1.879, comma, and 3.531. 3.531. But because this point over here is symmetrical, I immediately know that that must be negative 1.879. Again, still up at 3.531. Right? Again, you can verify that on the calculator if you want to. But again, providing those points of intersection sometimes just gives a little bit more accuracy, even though, again, all these purple points, right, all the numbers in the shaded region are really our answers. I hope that helps you with graphing systems of equations. Make sure you only shade, remember, the portion of the graph that makes both inequalities true. And it's not always going to be between the functions or sort of inside the circle. Make sure you look carefully for where to shade, either by checking a point or knowing if you're solved for y, you want all the points that are either greater than or less than your line. Okay? Talk to your teacher again if you have any questions, and have a great day.